Hello, my name is V. Together with my colleague Thomas, we would like to present the DAGOBAH 2021 system table and graph contest for efficient semantic annotation of tabular data. This work is a collaboration of Orange and EURECOM from France. Our annotation system consists of 6 steps as depicted in this figure. First, given a relational table as input, a pre-processing step is applied to each table metadata and determine the annotation targets. Then, the entity lookup collects candidate entity from the canonical graph for each target table cell. We use Elasticsearch to index the canonical graph associated with two Levenstein distance, shared byte and token byte. Next step, the pre-scoring flexibly evaluate each candidate with a confidence score considering multiple factors. Finally, 3 annotation tasks, CEA, CTA, CPA, are carried out using entity score and majority voting. We now present the core of our annotation system, that is, the entity scoring algorithm. Specifically, we evaluate the relevance of a candidate entity with a score. Our improvement in this year challenge focus on the context score of entity. We aim to quantify the contribution of neighboring cell to the target entity. For example, in the first row of the table, we consider the scoring problem of entity Q17, 15, 45, which is a candidate of band 4. We would like to verify if foregone from context is a meaningful context of this entity. In other words, we try to find a predicate path in canonical graph that connects target entity band 4 to entity foregone from context. To do that, we construct two subgraphs centered around these two entities. By merging the two subgraphs at intermediate nodes, we are able to figure out the connecting path. In this case, we have a 2 of predicate path, and 4 is the capital of territory band 4, which is located in foregone from context. Intuitively, by subgraph intersection, we already expand the graph of an entity. This includes not only direct nodes, but also indirect nodes that are 2 hop away from the entity. An entity has many table contexts and graph contexts. It's clear that each context contributes differently to the entity score. In DAGOBAH, we consider multiple factors that can have an impact on the entity score. This leads to a soft version of entity scoring. The factors are listed below. For example, a semantic context is more informative than the listed one, subject, datetime, and unit. A cell that is closer to the left side of the table has more chance to be a valid context of the target cell. A column that is highly connected to the target column should have itself shining more than the other poorly connected column. Finally, in the graph of target entity, predicate paths provide different information content. As shown in the figure, the path from band 4 to foregone from context is much more informative than the path from band 4 to unity site. We rely on the generality of intermediate nodes along the path to measure the information content of a predicate path. At the end of the scoring step, we will have the score for each entity. We combine it with a majority voting for the annotation task. Note that in CPA, our system supports multiple relation types, such as one-off relation or two-off relation. In CTA, we consider the type hierarchy on which direct type is more prioritized than ancestor type. In CEA, knowing that the scoring step exploits mostly local information in a table, we update the entity score using global table information such as CTA, CPA to return the final CEA. We evaluate the behavior of different entity graph contexts as well as the soft version of entity scoring on the Wikidata table and R table, the most useful and easiest copies of the two first rows. We report the CEA score on table evaluation. At expected, we are given a very good performance on our table and on annotation setting with nearly no difference. Meanwhile, in Wikidata table, system with richer entity graph are flexible self-scoring perform best. We provide in the table leaderboard our complete annotation score in row 1 and row 2.
As a multinational company, Orange deals with a huge amount of tabular data covering many domains in different languages and which are used by a large diversity of teams. To make table data interpretation widely used, we provide a DAGOBAH API for developers as well as an UI for everyone. We consider to open both outside the company, especially for academics in 2022. So let me show you briefly the UI where the user can leverage DAGOBAH to easily understand his data. Basically, he can upload tables in CSV, TSV, or XLS format, whether from gold standard dataset or a selected sample. It's possible to add tables with associated ground truth from SemTab or TDD, for instance, if you want to make a quick test of DAGOBAH. And of course, the user can upload data tables from local files. The uploaded tables appear in the dashboard, where he can first check the pre-processing result. That is to say, the table structure and the primitive typing, as well as some automatic data cleaning. Then he can launch the annotation processing. Once done, he can see the result of CEA, CTA, and CPA. Finally, he can display the corresponding graph visualization. Regarding our future works, apart from the continuous efforts on the usability, we also plan to improve our system through the use of dictionaries and pursuing the exploration of meanings approaches, focusing especially on language models applied to tables. In addition, we will leverage semantic annotation to make a bidirectional data augmentation, that is, enrich both knowledge graphs and tables. Finally, we have the ambition to build a hardcore corpus, as we strongly believe it could benefit the community with new challenges to cope with. That's it for our talk. Thank you for listening, and choose the light side, use DAGOBAH.